Hello, we're at Pre-Algebra Module 1 Review Part 2. First up, more fraction work. 5 2/5 minus 1/2. And number 12, 5 1/4 minus 4 7/12. Okay, so we have 5 2/5 minus 1/2. So we need to make these like denominators. Lowest common denominator is 10, so I'm going to multiply my first fraction by 2. And my second fraction by 5, and I will see that I have 5 4/10 minus 5/10. So at this point we are looking at borrowing or changing to an improper fraction. I'm going to show both methods. So if we want to look at the first method, borrowing, we're going to take that 5 4/10 and change that to 4 10/10. So change that 5 to 4 10/10 plus the 4/10. So that's going to be 4 14/10 minus the 5/10. So that will leave us with 4 9/10. Second method is to change to improper fractions. 10 times 5 is 50 plus 4 is 54 over 10. Minus 5/10 equals 49/10, and now we change to a mixed number. 10 goes into 49 4 times with 9 left over out of 10. Both methods are wonderful, so you get to choose the method you'd like to show. For number 12, we're going to see if we need to borrow again. So 4 and 12, I just need to change my 4, multiply by 3. So indeed I have 5 3/12 minus 4 7/12. So let's show the borrowing method. I'm going to take from the 5, giving me 4 12/12, plus the 3/12 gives me 4 15/12. Minus 4 7/12. 4 minus 4 is 0. 15 minus 7 is 8 over 12. And I'm going to divide both of these by 4. So my final fractional answer is going to be 2/3. If I choose not to borrow, that means I'm going to change them both to improper fractions. 12 times 5 is 60, plus 3 is 63 over 12, minus 12 times 4 is 48, plus 7 is 55 over 12. 63 minus 55 is 8 over 12, and again we're going to reduce that to lowest terms. So we'll end up with the 2/3. Either method is perfect. Number 13, you're finding the prime factorization of 300. Prime factorization, little factor trees, 2, 3, 5 are your prime numbers, your lowest ones. Give this one a try. So I'm going to take 300 and I'm going to go with my smallest prime number as much as I possibly can, which is a 2. So I'm going to divide this 300 by 2. 300 divided by 2 is 150, and I keep going. 150 divided by 2 is 75. Now I can't divide 75 by 2, so I go to my next smallest prime number, which is a 3. 75 divided by 3 is 25. I can no longer divide by 3, so I go to my next prime number, which is 5. 25 divided by 5 is 5. I circle my prime numbers, and with this method that I'm showing, you'll always have them on the left and down at the bottom, and I can write it as a product of exponents. So 2 squared times 3 times 5 squared is the prime factorization of 300. Number 14, can you hear the ice cream truck? You have 10 1/2 cups of ice cream, and you want to give out portions of 3/4 cups. How many portions can you give out? So you can imagine a big pot of ice cream, and you're scooping into smaller cups. Scooping, scooping, scooping. Every portion is the same. So what you're doing is division. You're taking away, taking away, taking away, taking away repeatedly the same amount. So we're going to take 10.5 and we're going to divide it by 3/4. And that's going to let us know how many of these small cups we're giving out. Remember, with division, we can't have it. We have to change to multiplication, but first we have to change to an improper fraction. So 2 times 10 is 20 plus 1 is 21/2 divided by 3/4 means I'm going to keep the 21/2, change to multiplication, and flip to my reciprocal. I look for cross canceling and I've got it. 3 and 21 divide by 3. 21 divided by 3 is 7. 2 and 4 divide by 2. 4 divided by 2 is 2. And I'm going to multiply my numerators. 7 times 2 is 14. So this means that I gave out 14 portions. Number 15, you're asked to find the lowest common multiple of 2, 6, and 10, and you can use any method. I'm going to show 2 methods. The first method I'll show is the one that is probably most commonly used when you have unlike denominators. And the strategy works well when you look at the largest number. So I'm going to count up by 10s. I'm going to start with 10s, not with 2s. And I'm going to make 10, 20, 30, 40, and I'm going to stop because I don't want to keep going if I don't have to. These other numbers are small, 2 and 6. Well, 2 is going to make anything 10 makes. So it's the 6 that we need to check. 6 doesn't make 10. 6 does not make 20, but 6 times 5 makes 30. So all of these numbers make 30, and that's our lowest common multiple. Alternatively, you can use the method that I've shown in class, which I love. I think it's pretty cool. It works well with 3 numbers, especially larger numbers. It's where we divide by primes, right? So we divide by 2s. So we're going to go ahead and divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 10 divided by 2 is 5. I can no longer divide by 2, but I can divide by 3. So I'm going to bring down that 1. 3 divided by 3 is 1. 5 does not divide by 3, so I bring that down. Now I can divide by 5. The 1s just get brought, and 5 divided by 5 is 1. When I hit the bottom row with all 1s, I'm done. I take the numbers on the side. 2 times 3 times 5, which is 6 times 5, which is 30. Either way, I'm finding the lowest common multiple. Number 16, Paulette bought 2.7 pounds of apples for $6.18. What was the cost per pound to the nearest cent? So we know the total pounds of apples she bought, and we know the total price. So we don't have any choice here. We're going to divide. So when we want to go down to the cost per pound, we're going down to 1 pound from 2.7. The decision is clear. We're going to take $6.18 and we're going to divide by the 2.7 pounds. And we're going to long divide with our decimals. So 2.7 into $6.18. Remember, we can't have a decimal divisor. We pop that decimal out and accordingly 1 decimal place out in the dividend. We put our decimal up high. For good measure, we're going to be adding at least 1 0. But they're asking us to the nearest cent, so we're probably going to be adding 2 zeros unless we get a 0 remainder. So let's start and see where we end up. 27 into 61 goes twice. 2 times 27 is 54, and we're going to subtract 61 minus 54. So I'm going to borrow here. 11 minus 4 is 7, and I'm going to bring down my 8. 2 goes into 78. It seems like it would go 3 times, but it doesn't. Still 2 times. 2 times 27 is 54. So we're going to subtract again. And we're getting close, but we're not there. So at 24, now we bring down this 0. 240. 27 goes into 240 8 times. 8 times 27 is 216. We subtract now. We're going to borrow here. Give. 10 minus 6 is 4. 3 minus 1 is 2. We've got 24. We got around to the nearest cent, so we've got to go one more spot to see if we have to round that 8 up. And we're going to end up with that 240 again. So that's going to be another 8. We can just stop. We don't need to continue on. We've got the number we need to be able to round. We're rounding to the cents. So that 8 is going to push our 8 in the cent position up. So our final answer, the cost per pound, is going to be $2.29 per pound. Number 17, Thomas bought 2 1/3 meters of cotton fabric and 3 7/8 meters of wool fabric. How much did he buy in all? So we know the quantities in meters, and they're asking us in all, in total, so we're going to be adding these two numbers together. So 2 1/3 plus 3 7/8. We have unlike denominators, so let's change them. We're going to be multiplying them by each other. So that will leave us with 2 8/24 plus 3 21/24. If we add our whole numbers, 3 plus 2 or 2 plus 3 is 5. We add our numerators, 8 plus 21 is 29. And then we can change 29/24 to a mixed number. That's going to be 1 5/24. Add with the 5, so our answer here is going to be 6 5/24. And this is meters. Alternatively, when you're at this stage here, you can change to improper fractions. The numbers get larger though, so changing back to mixed can sometimes be a little bit harder, but that's okay. 24 times 2 is 48, plus 8 is 56/24. And then 24 times 3 is 72, plus 21 is 93/24. And then you're going to have to add those two numbers. 56 plus 93, it's 149/24. So it's quite big. With a calculator, this is no big deal, but without a calculator and showing the work, this can take a little bit of time. So 24 goes into 149 6 times with a remainder of 5/24. So in this instance, I think carrying is easier, but you can always change to improper fractions if you like to avoid carrying and borrowing. So we've got one more short video to finish off our module review, so I hope you'll join me with those questions in our next video.